Welcome to the Data Structures course. Today we are going to see Unit 2, that is Linear Data Structure. So in this unit we are going to see representation of one-dimensional array, two-dimensional array. In multi-dimensional array we are going to see three-dimensional arrays, then row major representation, column major representation, and array. How do we find address of a particular element? Okay, that is 2D array address calculation. So let us now see one-dimensional array. So as we know, array is a linear data structure that stores data elements in sequential manner. Fine. So let us see one-dimensional array. How do we declare one-dimensional array? We declare one-dimensional array as data type, array name, and size of the array. For example, let's say we want to store 10 integer numbers. Then data type would be integer. Array name is marks, which stores 10 elements in the array. Okay. How do we represent one-dimensional array in memory? So we can have array which looks something like this, in which we will store 10 elements, and all the elements are stored at specified index, and the index of arrays start with zeros, in which first element will be stored at 0th index, second will be stored at first index, third will be stored at second index, and so on. So if there are 10th element, then 10th element would be stored at index number 9. So in order to access them, we have to write array name and index number. If we want to access 5th element, then in that case we will write marks at index 4. So marks at index 4 will return us what? 5th element. So this is how we can represent a one-dimensional array in a memory. Now how we can find the address of the element of the one-dimensional array? For that we have the given equation, in which A represents the array, K represents the index of the element whose address we want to find. Then B represents base address, W represents size of the element, and lower bound represents the starting index of the array, which is going to be 0. Okay, so these are the notations in the equation, in which we will take base address and we will add the base address with this equation, in which we will subtract index from the starting index, and then we will multiply it with the size of the element. So now let us see the example. Given an array integer marks which is having these much elements, calculate the address of marks 4 if the base address is 1000. So in this case we have to find the address of element which is present at index 4. Okay, and we are given base address as 1000. So let's see. We know that storing an integer value requires 2 bytes. Therefore we will take W as 2. We will take W as 2. Fine. So we can calculate the address of element of one-dimensional array by putting all the values in the given equation. So we want to find address of the element which is present at index 4. For that we have to take base address as 1000, which is already given, size which is 2 bytes, K is the index whose elements address to be found is 4. Lower bound means starting index of an array will be 0. Okay, so in that case 1000 plus 2 multiplied by 4 is 8, so that will be 1008. So the fourth element, the element at index 4, will be stored at 1008 address. Okay, so if we calculate this manually, and if this is our base address 1000, and if each element is of 2 bytes, then this will be stored at 1002, this will be stored at 1004, this will be stored at 1006 and this will be stored at 1008. So this is the element which is present at index 0, 1, 2, 3 and 4. So the element which is present at index 4 will be having address 1008. So the answer is 1008. Let us now see two-dimensional array. Syntax of declaring two-dimensional array is data type, array name, maximum rows and maximum columns. So for example, let's say if we want to create two-dimensional array or 2 cross 2 matrix, okay, then we will specify data type, that is integer. If I want to create an integer array, then array name would be marks and it can store 2 rows and 2 columns. In total, it can store 4 elements. Okay, so this is how we will declare two-dimensional array. And how do we initialize two-dimensional arrays? So we can initialize means we can assign values to this two-dimensional array like this in curly braces. So as the size of two-dimensional array is 4, we will have to initialize it with 4 elements, and these elements will be stored like this in memory. Okay, this will be element 90, this will be 87, this will be 78 and this will be 68. Okay, and index, these elements will be stored at, this is 0th row, first row, this is 0th column and this is first column. So 90 is stored at index 0, 0, 87 is stored at 0, 1, at 10 index we have 78 and at 11 index we have 68. So this is how we can initialize two-dimensional array, and this will be represented like this in memory. Okay, so in general we can represent n cross n matrix or two-dimensional array as this index. So the index will range from 0 to n minus 1 in case of n elements in row, and we have 0 to n minus 1 columns. Okay, so in order to access this first element, we have to write array name, row number and column number, that is A of 0, 0, and that will return us the first element of the matrix. Okay, in order to get the last element, what we will write? Array name, row number, that is n minus 1, column index, that is n minus 1. Okay, and we will get the last element. So this is in general representation of n cross n 2D array. Okay, now in 2D array we have two types of representation, that is row major representation and column major representation. If the elements of an array are stored in memory row by row, then it is row major representation, and if the elements of an array are stored in memory in column wise manner, means column by column, then it is called column major representation. Let us see column major representation. Okay, so in column major representation, elements will be stored column by column in memory. Okay, so first of all, element at index 0, 0 will be stored, then 1, 0 will be stored, then 2, 0, 0, 1, 1, 1, 2, 1, 0, 2, 1, 2 and 2, 2. So this is how elements of an array will be stored in the memory. Okay, now let us talk about row major representation. So if we have the same 2D matrix, that is 3 cross 3 matrix, in that case, if we want to represent this in row major representation, then elements will be stored in memory in row wise order. So first of all, element at index 0, 0 will be stored, then element at 0, 1 will be stored, then 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1 and 2, 2. So basically column major representation stores element column wise from top to bottom. Okay, and in row major representation, elements are stored row wise from left to right. So this is how we can represent 2D array in memory. So now we will see how can we calculate address of the 2D array's element. Okay, so there are two types of examples which are asked in 2D array address calculation. First type is the type in which usually the number of rows and columns of a matrix are given as this. So we will be directly provided with the total number of rows and columns of the matrix. If we are given 8, 10, 15, then we have to find address of element which is present at 10th row and 15th column. Okay, so in this case we are directly provided with row and columns of the given matrix. Fine. So let us see the notations to calculate the address of the 2D array element. B represents base address. I represents row subscript of an element whose address we want to find. Okay, W is storage size, M is total number of rows of the given matrix, and N is the total number of columns of the given matrix, right? If the array elements are stored in row major order, then equation to find address of element present at index I and j will be given as base address plus size. N represents number of columns, I is the index, j is the column index of the element whose address we are going to find. Okay, so here I and j represent the index of the element whose address we are finding. Okay, and this is the equation when the elements are stored in row major order. If the elements of an array are stored in column major order, then in that case we can find address of the given element as base address plus size, then number of rows multiplied by column index minus 1 plus row index minus 1. Okay, so these are the equations to find address of the elements which are stored in row major and column major order. Now let's take an example. So consider a 20 cross 5 two-dimensional array marks which has its base address 1000 and the size of an element is 2. Now compute the address of the element which is marks 18,4, assuming that the elements are stored in row major order. So we are given that elements are given in row major order and we want to find address of the element which is present at index 18 and 4. So in this case our I will be 18 and j will be 4. So now if we want to find address of element which is present at index 18 and 4, what we will do? We will take base address, that is given as 1000. Size of the element is 2 bytes, so we will take W as 2. Then the value of N is what? Number of columns. So this is number of rows and N is number of columns. So we can take N as 5. Then index, I represent the row index and j represent the column index, which is this. Okay, so j is what? 4 minus 1. Fine. So what can be the answer? 1000 plus 2, 5 into 17 plus 3. So it is 85 plus 3, which is 88. Okay, and 88 into, okay, so 2 into 88 would be 176 and the answer we will get is 1176. So 1176 is the address which this element is present. Okay. Now let us see type 2 examples to find address of 2D array element. So for that let us see the notations first. So these examples will be given like this. If the number of rows and columns of a matrix are given as range, which ranges from lower bound of row to upper bound of row and lower bound of column to upper bound of column. So if we are given this range, then in that case let us see what can be the equation. Okay, so LR represent the lower limit of row, LC represent lower limit of column, and as we have already seen, B is the base address, W is the size of element, M represent number of rows, and N represent total number of columns. So in such examples, first of all we need to find number of rows and columns. Okay, so first of all we will find value of M, and that will be given as upper bound of row minus lower bound of row plus 1. Okay, and value of column will be given as upper bound of column minus lower bound of column plus 1. Okay, so the equation of row major system would be base address plus size into number of columns into row subscript minus lower bound. So only one change is there, that in previous equation that was I minus 1, and here we will have lower bound of row in place of 1. Okay, and here in place of 1 we have lower bound of column, and that minor change will be in column major system also, and that will be B plus W into I minus LR plus total number of rows multiplied by column subscript and lower bound of column. Okay, so this is the equation when we are given range in rows and columns. Let us now see the example of type 2. An array which is given as minus 15 to 10. So in this case, this is lower bound of row, this is upper bound of row, this is lower bound of column, this is upper bound of column, and it requires 1 byte of the storage. So in this case our W is 1 and the beginning location is 1500. So the base address is what? 1500. So determine the location X, 15 and 20. So in this case 15 is I and J is 20. So first of all let's find value of N, which is upper bound of row minus lower bound of row plus 1. So upper bound of row is 10 minus lower bound of row is minus 15 plus 1. So 10 plus 15 is 25, 25 plus 1 is 26. Let us now calculate the value of N, which is given as upper bound of column minus lower bound of column plus 1. So upper bound of column is 40 minus lower bound of column is 15. So that is 25 plus 1 is equals to 26. So in that case we have value of M and N as 26. Okay. So now let us have all the values together. Base address is given as 1500, size of element is 1 byte, I to be found is at index 15, J is at index 20, lower bound is this, lower bound of row is minus 15 and lower bound of column is 15. So we need all these values in order to calculate the address for row major and column major system. Okay. So and we will put all the values in this equation. So that is 1500, W is 1, N is given as 26 as we have calculated, I is 15 minus lower bound of row is minus 15 plus J is 20 minus lower bound of column is 15. So now let's calculate all these values together. So that is 1500 plus 1, 26 into this is 15 plus 15 which is 30, then this is plus 5. So 1500 plus 1 into 780 plus 5, that is 785. Okay, so if it is 785 then 5, 8, 2, 1, that is 2285 is the answer in row major calculation. Okay, now let us see how to find column major. So answer of row major is 2285. So the answer we got in case of row major wise calculation is 2285, means at this address element X1520 is stored. Now let us see the address calculation in column major wise calculation. So let us now put all the values in this equation. So base address is 1500 plus W is 1 into I is given as 15, so that is 15 minus lower bound of R is given as minus 15 plus M is 26 into J is 20 minus lower bound of column is given as 15. Okay, so now let's reduce this. So this is 1500 plus 1 into this is 30 plus this is 26 into 5. So this would be 1500 plus 30 plus 30. 30 plus 130 would be 160. So the final answer would be 1660. So the answer in column major calculation is 1660.